Okay, so what if we have something that's not telescoping and also not geometric? Well, the answer is going to be quite a bit more difficult. It's actually going to be quite rare for us to find sums. And often the best we can do, especially in this class, is to just determine whether the series converges or diverges. Okay, does the series add up to a real number or not? Okay, so we're going to establish a bunch of tools over the next few sections that allow us to determine whether a series converges or diverges. So the first tool is something called the test for divergence. Theorem 6, I believe, in your textbook. So test for divergence. So what does this test say? Okay, if, so we'll start by saying given a series, summation a n, if the sequence, let's start over. If the limit of the sequence, limit an, is not zero, or that's, if the limit just doesn't exist at all, then summation an diverges. Okay, B, if limit of an equals 0, then unhappy face, this test tells us nothing. Okay, so back to my example. Let's go blue here. Okay, so in this case, we're going to extract the sequence. Now, it's going to be very important that you have clear in your mind what is a sequence and what is a series. Okay, the sequence, an squared plus 1 all over 3n squared plus 1 is equal to, if I divide top and bottom by n squared, I get 1 plus 1 over n squared all over 3 plus 1 over n squared, which goes to 1 over 3. So the sequence and converges to 1 over 3. Therefore, by theorem 6, summation n squared plus 1 over 3n squared plus 1 is convergent or divergent. Okay, so before I answer that question, okay, remember sequence. Here's the sequence. Here's a sequence. This sequence converges to 1/3. So limit of an is not equal to 0. So we conclude that the series, the corresponding series, diverges. Okay, so very roughly speaking, look at what I'm underlining in red here. This is think of it as an infinite sum. Okay, you're adding up an infinity of terms, and those terms themselves are not approaching zero. So our test for divergence says that there is no hope that this infinite sum will add up to a real number in that case. Because the test for divergence basically says, if you want an infinite sum to actually add up to a real number, not diverge, at the very least, you're going to need limit of an to be zero. Part B of the test for divergence says that that's not good enough. Okay, just because so part B here I'm talking about, just because the limit of an is zero, that's unfortunately not good enough. I'll give you an example. Okay, this is a exclamation mark summation 1 over n. This is called a harmonic, or the harmonic series. Diverges even though lim an is lim 1 over n, which is 0. Okay, there's a nice proof of this. It's a bit involved for a lecture. It's 713. See page 713. This is a nice little demonstration. I wish I had time to do it, but I don't. Okay, so what's the take home here? The take home is, well, what I've written. Okay, even though the limit of the corresponding sequence is 0, that doesn't mean that the series converges.